はい、おはようございま
Good
す。
morning, everyone. DevSecOps Tokyo 2022. Welcome to this event. I would like to start. DevSecOps Days now marks the third year, starting from 2020. It was October of 2020 that we did the first DevSecOps Tokyo event. So we did the first time in 2020. It was March or April period. Now we were hit by the COVID-19 outbreak, and around 2021 of January, I went to the Carnegie Mellon University. And today we have invited the presenter, Mr. Hasan Yasar, whom I met back then. And I told him that, well, there was the DevSecOps event held all over the world. So I said to Mr. Hasan that maybe we could do this in Tokyo as DevSecOps, and it was the January of 2021 that we discussed over that, and actually we did it in October of 2020 from the Carnegie Mellon University, where the people supported us, and they are the sponsor of this event. In addition to that, Scilab SEI that they are available under Carnegie Mellon, and tomorrow the second person, well, from the second person, Mr. Nicholas Shannon, is going to present tomorrow. When I met with Hasan-san for the first time, Hasan-san said that it is an important theme for the software development from DevSecOps perspective. As for the DevOps lecture-wise, it was the first time in the world that Hasan took that teachership. It was about 20 years ago. And prior to that, I visited the DoD, and that is the second from the last tomorrow, where we invite Mr. Nicholas Shannon. It was 2021. No, it was September or October of 2019 when I visited the DoD. Nicholas was working over the transformation at DoD, and the keynote speaker that we invited tomorrow under the DevSecOps transformation. He was the former chief software officer at the U.S. Air Force, and the system for the weapons are created by the DevSecOps idea. With such Mr. Nicholas that I met, followed by Hasan-san. So I told Hasan-san that when I went to DoD the other day, Nicholas is involved in the DevSecOps, and I told him this, and Hasan-san said that, well, I meet with him every week or every month. So we would like to coordinate together in order to organize this type of the event. So that was the origination of the DevSecOps Tokyo. Today we have invited Mr. Hasan.
This is the third year, and we met in the, as I said in Japanese just now, we met in the January 2020, and it's going to be, this is a third time, and
right.
we've been together for 2 years now, and this is third year. Do you have any word to start over the session?
Sure. Thank you so much, Yusuke, for the opportunity. I'm really happy to be part of the DevSecOps Days event. As you know that we are doing the DevSecOps Days all around the world, and Tokyo is one of them we have been doing for the last 3 years. I'm very, very, very eager, and I'm very excited to see a lot of participants, and for interest-wise, and also I see the trend about using DevSecOps frequently, it seems. I'm really excited to have in the Tokyo, and as well as all around the world. As I said, DevSecOps Days is a community event, and we do almost 10 times in a year, various cities and all around the world. It is increasing the community awareness of building a secure software. I know we're going to talk a lot today. We will talk a lot tomorrow as well. to build up a secure software, building up a secure product is really requiring a DevOps capabilities. And the biggest things is requiring DevOps capabilities is meeting the customer needs, meet the business needs, but we often ignore the security. So purpose of this community event, as you led, Yusuke, it is really bringing security into the production, into the software, which we cannot ignore it anymore. It is hurting us, it is hurting everybody if we ignore the security. Now we're going to learn a lot what needs to be done to build up a secure product and secure system. So I'm really excited to be part of this event, Yusuke. I'm really excited to hear a lot of participants as well. We see a growing interest last couple of years. I'm very lucky to meet you and looking forward to have a great sessions today and tomorrow.
Thank you. ですね。今年の参加者はですね。
Thank you very much. As to the number of participants, we have more than 1,500. The latest number of participants, it is not shown yet, but again, the more than 1,500 registered. With respect to today's session, I am going to discuss up until 9:30. For those people who have joined for the first time on DevSecOps event, after that, Hasan is going to talk in more substantial manner by showing the actual demo. And then we have some break. And lastly, we will invite Mr. Tomabechi to have a lecture. So what means the DevSecOps now, with some history that Tomabechi-san is going to discuss. Now I'm looking at the live streaming. It looks like there is a steady increase. So we'd like to start. So I'm going to cover the first part.
Well, I forgot to say something very important. This time, we have simultaneous translation, and the distribution technology is we are having NHK's technology in distribution, and this is very important session. And all speakers are joining on as volunteers, and in simultaneous interpretation and the distribution. These services, we need to incur the cost, but this is really due to the support of sponsors. In order to promote the DevSecOps in Japan, they are seeing significance, and they agree to raise funds. And these sponsor companies I would like to mention. First, Platinum sponsor, NTT Data, BrainPad, and the Cognitive Research Lab. I belong to Cognitive Research Lab, so my company is also funding this community, and the BrainPad and the NTT Data. And this big conference, some people did not know that these type of conference are being held, and this has a great significance to Japanese society, and those are the messages that I just received. And NRI technology at the NRI Nomura Research Institute. This is a Nomura Securities affiliate on the technology, and NRI Secure. They have a DevSecOps department, and they are taking this opportunity to join that. And GMO Security, ERA, they joined GMO Group. And Yoga, they have a high-rise tower office. And GMO Group, needless to say, they are a big internet company, and HR2 and the profile company which I manage, and the startups also like this event, and as a special supporter, robust intelligence. This is a Silicon Valley enterprise company. Tomorrow, we will be joined by the founder, Mr. Oshiba, and the Michiruka Security. 3 years in a row, we are getting the lectures and the NTT data and are secure. Also, they will join as speakers. And you are viewing this event free of charge, and this is thanks to these great sponsors. So if you have a project that you want to get the support of these technology companies, please check out NTT Data and NRI Research and so forth for their services. Now I'd like to move to my presentation. Now let me start. DevSecOps for the first timers, 2023. DevSecOps, why it is important and what is it? And as an operating entity, this is going to be covered by Hasan, and I will cover its flow and its current positioning. Last year, I got an article from Hasan to this book regarding the acquiring immunity to cyber attack. This is a book that I published last year. This, in terms of the number of the publications or the number of volume, it's not growing so much, but I'm getting a lot of reactions from academia and also from the government, bureaucrats. I get a lot of messages that they've read this. And I also got some invitation based on this book publication. In a study session, of course, and including getting an invitation as a lecturer to study session. So from 2 years ago, when we started, now the interest of the market is much bigger. And as a testimony, this is a material of a digital agency regarding this cybersecurity strategy, security by design, and security measures, including DevSecOps. That's what they say in this material. And cybersecurity for all. So we need to start thinking about how we build the software. That's what the government ministry is and the agency is saying. And the digital agency is a cross-functional body covering all the ministries and agencies. And resilience need to be improved and real-time monitoring. So cybersecurity is important, and also the resilience, because of the possibility of the fact that we may be hacked at any time. And this type of notion is becoming increasingly aware to the digital agency as well. And this has been what we were saying for many years. And so now people are getting much better understanding about what we need to do and where we are. This is a 2022 context. In 2022, in terms of DevSecOps, in order to understand the meaning, starting from 1950s, the business use or commercial use of computer, I would like to have a quick look back. For software development methodology, waterfall, agile, and DevOps. And now it's evolved to DevSecOps. Waterfall, it is like constructing a building and water running from the top to bottom. And it is about that we are being more adaptive to the external environment and the external environment. And so agile is evolution of a waterfall, and the system need to get updated and need to change with the demand and environmental changes. And now the automation need to be introduced. That's DevOps. And starting in 2015, we started talking about DevSecOps regarding the requirement on security. And the big bugs, huge bugs, we need to patch timely and quickly. And this security patches need to be automated in the pipeline. And this is what where we are. And initially, the first use of computer, the military use, is famous on the Alan Turing in Germany. Enigma is the coding. He encrypted with his computer in 1940, early 40s or late 1930s. And that was during World War II. And then after 10 plus years, commercial computer became available for the National Census Bureau of the US and also ballot counting for the election for the President Eisenhower. And the first business use was in 1954 for GE in a Kentucky state for payroll calculation. They were using people for manual calculation, and they started automated payroll calculation. This is the first case, I believe, and that project was awarded to Accenture. I was there, and at the time it was Andersen and the company. And this was a first trial for them. And they said that they don't need to be paid because this is the first time for them, but they were willing to pay, cover the expense at least. And then this is what the Accenture did.
So Univac 1 was used. As for the payroll calculation, you input attended record and collects attendance data. It was a bit cumbersome, but on the left-hand side, it was decided to digitalize. It started from 1950. Now it goes to the right-hand side. Now delivering in cash, well, it would be okay to put into the bank account and decided to automate. When it comes to Japan, what is the trigger was the 300 million yen. It was stolen at Toshiba. 300 million yen worth of the bonus was stolen. So to deliver cash with the vehicle is something risky. So we often say DX or digitization and DX. That has been said for the last 50, 70 years. So it is going to be promoted and advanced moving forward. Different processes are available. For example, the accounting, the inventory, sales and management. Now there is no paperwork at office, and the inquiries through the phones are now changing to the system where the search is done, or maybe you'll find by search to find things that you need. We had some slips in paper basis, however, that is gone now. With respect to the software development process, firstly, starting from the top, whatever it was decided, it is built up. While doing so, what is a very much similar process should be put together. If there are some similar processes, it would be better to put into one. So that is the so-called object-oriented program. As much as possible, to utilize the code written to reuse again and again. For waterfall, it is coming from from the top to down, so prevent the rework by running a counter to the process. So to reuse the behavior on different processes are not to be written in different areas because might require some rewriting. I was involved in software development. It was in 2000 or the early 2000, or maybe the latter half of the 2000. The object orientation was not well permeated, and to change the Japanese era name to the Western name of the era, when it was changed to Heisei or Reiwa era in Japan, we found that it would be a very challenging job, and I faced that situation directly. So therefore, they say they would like to centralize as much as possible. As I mentioned earlier, in 1950s, starting from there, from mainframe scratch development, and in 70s, ERP package development emerged. In 90s, ERP came to Japan, and in 2000, internet, mobile phone, and in 2010, ASP, SaaS, smartphone, and cloud is now permeated with IoT, sensor, and so on. Now, we have AI, Web3, metaverse, so digital currency or the virtual currency for cashless purpose. Throughout this history, well, of course, waterfall is available. However, with the spread of the internet, it has been changed to Agile, and then 2020, so DevOps came. Now, cyber threat is getting a serious threat than DevSecOps. Now, AI is more spread. For AI's development, security should get involved in. Therefore, MLSecOps, this is the new idea. This is the successor of the model where we should implement the security element. Now, for Agile, they have declared Agile software development. As you find here, there are some declarational expressions rather than the following a plan, but address the changes like waterfall. This is something that we did. This is something created according to the specification, and we can't do anything at all. That was 20 years ago, it's idea. When you go to the ski resort place, and they say maybe it would be better to change the software development process. Again, it was 20 years ago. This is the history of it. Now, from there, it made some evolution. Now, the development and operations are integrated in order to automate. In addition to that, security will be put on top of this. And starting from 2015, DevSecOps started. Those people who are going to speak today and tomorrow, they would discuss what is the underlying concept of DevSecOps and so on. So I hope that you will enjoy that. With respect to software development, why it is important as a topic. This Mr. Mark Andreessen, who founded the Netscape, the initial browser for internet, where he developed. According to him, in 2011, he said that's why software is eating the world. For the next 10 years, many industries will be destroyed by software. And Silicon Valley's new companies are the one to act as a destroyer. That would be the increasing case. That's what he said. So what is happening now? For the number of the units, Tesla is very much limited. However, to the market cap, Tesla is higher. Tesla is producing hardware as well as it could be said it's a software company. Now, after Tesla was launched in the market, Tesla has been evolving, and the value is heightened after the purchase. For example, the capacity of battery, it is saved, and we will be able to open to you free of charge, and you will be able to recharge anytime you want because it's free of charge. Maybe this is just Elon Musk's idea, and with his decision, it was made available. And Toyota, Ferrari, BMW, Daimler, at the time of the shipment, the latest software is mounted. But the Tesla software, even after the sales, there will be an update of the functions. And therefore, software companies are now eating the real world. It's not just the EV. Well, if you think that it is just the EV, I don't think that you understand the essence. With respect to Toyota or the Daihatsu, Toyota's chief engineer, I think it was Prius that he was involved in, and he is the vice president of Daihatsu, whom I met with him last year to have a discussion. A person who are looking to this DevSecOps, he or she introduced me to that Daihatsu executive. According to the Toyota's recognition, hardware is important, but for software, since I was the chief engineer and involved in this, I have not much paid attention to it. But when he discussed with me, he understood that the software world is very in depth. And he was retired. However, he said I need to listen to the world of software. But before, he thought that it's something that not require much attention. As a Japanese company and Japanese manufacturer, this might create some opportunity, I think. But Tesla is ahead of the Japanese companies from that point of view. Now I'm talking over software topic. But as to hardware that you're looking at here, or you have the mobile phones, the different hardwares are available. On top of that, OS and Windows, Mac, Linux, and then Excel is activated online, Google. And then on top of that, web, the software on the web like Instagram or the lines. So the hardware is on top of the hardware on top of it, software. Through the cloud evolution, hardware could be treated like software. So that is a major changing point. So what does it mean on the cloud where a server is there? By writing software programming, infrastructure code, or this so-called infrastructure code, then maybe by a minute or by a dozen minutes, you'll be able to have a good grasp of the hardware, a block of hardware where the cloud it is available on the cloud. So it is once you write a code, hardware is usable on thousands of cloud per minute or per hour, and a server will be launched. So even hardware, it is now coming into a part of software. That is the era that we face.
So regarding the IAC, Hasan may cover after myself, but they're looking at the sample code. This is AWS code. You only see 20 lines, but 175 lines to run server. So this is what we do. The Tesla and the GAFA people are doing this. So per day, 45,000 improvements, and now it's probably higher. So tens of thousands of improvement done each day. And what sort of a state that we can say software development is good or bad? The first, deployment frequency, on demand, anytime. That will be high level. Low is once a month or to every 6 months. In Japanese mega banks, a system upgrade, typically done on a golden week and year end or beginning of the year. So they are in this low category, and their time to restore service, KDDI, they suspended the business for several days. So I would say that's a medium, and LS1 level. The less than 1 day will be high. And Japanese companies are good on this aspect. Change failure rate, they're low. Facebook and GAFA, the 15% or less of failure rate is acceptable. That's the risk failure tolerance. And Japanese tend to be a perfectionist, but we need to take an optimum balance. CI/CD in DevOps and DevSecOps, these are important concepts, and I believe Hasan will show us its demonstration. Continuous integration, This is a concept or system, and then continuous delivery and continuous deployment. When it comes to software, when you write a code, there is a process called compiling. There's some computer language don't need compiling, and then you conduct a test and merge, and then you bring that to the operatable environment, to a production. And in the meantime, you've been doing the test several times and then manually moving to the test environment and then manually moving to production environment. And all of these are to be automated by setting the setup in a backstage so that it can be done automatically. And automating the software development cycle, that's CI and CD. Later, we will show you. And what we need to know is a microservice architecture. There are various services like a YouTube or Facebook. Inside the YouTube, there is advertisement or premium membership and distribution and analysis. And also for advertisers, there are various modules, and they are not built singularly, but the microservices is putting into pieces, and they're done separately. You create an interface, and you create a backstage. And microservices means that in the units of small teams, like a 2 pizza rule, that is the size of the team per team. According to the Google survey, they say many say that the 5 to 10 people size team is optimum, and 20 people per team for application. Those are the size we see in Japanese companies, but I think the team size is getting smaller. This microservices, there are numerous numbers of microservices. And this can be an issue that the microservices can be too crowded, but independent deployability is my translation. You don't have to worry about other services. You just have to focus on your own team of 5 people or 10 people to establish architecture that's improving efficiency. But looking at the overall, it may be too confused or disintegrated or difficult to understand the overall picture. That may pose a different problem. In 70 years of software development history, what we see consistently is automating manual work. The manual payroll calculation got automated, and the manual software upgrade is automated in the CI and CD. Manual infrastructure building is now moving to cloud and IAC, no longer manual. And manual vehicle driving is introduced. Tesla introduced autopilot. So we are in the destiny to make things more and more automated. That's the history of 70 years. And also the structures that are too complex and too gigantic is now getting more separated or simplified, making it more like a function or classes. They're same processing, then treat them as the same function and categorize them into classes for the same type of work or processing and treat them as a object. So simplifying or the bundling and the spaghetti structure, software architecture is now separated into microservices. A large number of people in one team is not manageable. So it is now separated into pieces, putting into pieces to 5 to 10 people size teams. That's been consistently occurring in the past 70 years. And cybersecurity is now increasingly important. So this is also the same trend we see in the security front. Google every year published State of DevOps 2022 theme. This is now treating this an issue. The codes now being more and more reused. Some codes written by someone can be reused, not need to be recreated. So more and more open source. But at the same time, vulnerable codes are spreading as well. So Log4j bug. Last year, it was found, or beginning of this year. And everyone using the same code and everyone has the same vulnerability. So we had a wholesale catch on that vulnerability. And running software supply chain. What's happening on the supply chain side? We need to ensure the safety and security at the root. That's what the GAFA is talking about. Tomorrow, NTT Data Secure we'll talk about this supply chain security. So please stay tuned. DevSecOps Future 2021, Gartner hype cycle is like this. State of enlightenment. We are now over the disillusionment. And tomorrow, you see many cases. So in Japan, now we are in a phase to just execute. And the digital agency also say that, and the lawmakers are having a high interest, and many government bureaucrats also are very interested in this. So that's where we are. So that intelligence, please learn as much as you can, and I also would like to learn as much as I can. Regarding DevSecOps in detail, please read this book, including Hasan's article, and I also wrote a book on AI and machine learning. So what is AI and what is machine learning? Please also get this book as well. In June this year, it was translated into Chinese language. So Chinese people are now reading my book, and size of population is 14 times bigger in China than in Japan. And I haven't gotten any reaction on Chinese version, but I think it is moving well.
As
I mentioned last year, but Dr. Linton Wells and Hasan-san sessions are available. Sorry, I overran as the first session, but this is all. Maybe you have some questions, but we'd like to accommodate with Hasan's session. Now that said, this will be a long two-day long session, but enjoy.
From audience now. And
thank you.
Yeah, he's asking about SBOM, and he or she just got to know about SBOM, and what is the impact of SBOM? He or she wants to know.
Sure, I can answer right now if that's okay. So
yeah,
SBOM is a software bill of materials. That's kind of extension of the meaning of SBOM. But in the meaning of SBOM or software bill of materials means when we build up a product, a software, we usually using many dependencies. Like you're not writing everything from scratch. We are using the libraries, we're using the frameworks, and our applications work in a stack. Like we have operating systems, we have dependencies. So we need to know where we're getting those dependencies. Let's say we are running a web applications, like with the shopping cart as an example. But shopping cart web component depends on other libraries, maybe Angular framework, maybe Java, maybe Django framework, other frameworks. With the security problem, if you don't know what type of libraries we are using in a production environment, or what is really constructing our application that we build, it is becoming a problem. I think you mentioned the log4j, Yusuke. Log4j is one of the dependencies, and we need to know which version that we have, where are we using those libraries, like which server that we have, which application that we are using it. So we need to keep track those libraries. That's basically bill of materials. If we know where we are using these libraries, if we know the version of those libraries, we can patch those, we can really track those libraries. So we should be ready with respect to any vulnerabilities we maybe discover later on. That's what the SBOM is really giving us. To achieve the SBOM, we're gonna have many talks tomorrow, and we need to integrate the SBOM practice into our DevSecOps infrastructures, and using the infrastructure as a code, or using the build mechanisms. And I'm gonna demonstrate what the build mechanisms looks like, how can we keep track those libraries, where we can store, what IAC means. All these configurations is really helping to build up the SBOM capabilities. So short answer, we need to know what we are using it in our production environment, or where we are using in our application that we build, what build is contained besides our code that we have.
Okay, thank you. So it's already 10 minutes late. Sorry.
All right, no problem. I'm gonna share my screen.
Yeah, I just pass over to Hasan, and let's see your demo and your explanation.
Sure.
Yeah, and we want to be, I'll speak in Japanese now. 皆さん、こういう感じですね。
This is how we are going to work in an interactive manner, and then we'll be able to know your questions. It was a great question. Whatever you have the interest, or whatever you would like to know, we are going to cover and respond. So would you please use chat box. People who are looking in Japanese, we have 278. So if you say that you have any question, please let us know. And the question raised, this person question raised, I said, thank you.
Yeah, you have about 1 hour and 20 minutes, right?
All right, thanks, Yusuke. Again, there's a lot of contents. Let's see how much we can cover in a short time frame. Maybe we can continue further, maybe another days have more interactive sessions. I'm available to talk about that, because I really like to talk about this topic, because very important to me. I know you already gave my information, just gonna skip this. So quick things, what is really DevOps? I know you cover up Yusuke, but I have to say two things in what DevOps means. It is a set of practice and principles. So when we say the practice and principles, like a continuous integrations, continuous delivery, continuous deployment, anything you mention about the continuous are the common practice of DevOps. The principles that we are talking about is infrastructure as a code, automation, monitoring. These are the typical principles. The combination of those practice and principles, when we communicate with all stakeholders, when we say all stakeholders, we are talking about developers, architect, security expert, business managers, risk people, the human resources. It's really important to build up the workforce. Whoever has a right to say in a production lifecycle, that's what that means. So DevOps is really a mindset. It is a mindset, is giving us an ability, giving us a capability, using the common practice and principles so we can build up a high quality software. DevOps doesn't mean we go fast and deliver on quality or bad software. We have to build up a very good software or high quality software. That's important. So let's dive into the more DevSecOps pieces. When we say the DevSecOps, a little bit clarification here. As a community, when we build up so much software and product with the needs of the business, with the needs of the, the requirements, we often ignore the security elements. We often ignore to getting a security
Hasan,
into our practice. Yes, please.
Would you switch to the slideshow mode?
Sure, I'll do.
Yeah, I think the audience can see bigger.
Okay, how about now? Can you
It's now
see
the
the
presentation
screen?
mode.
Okay, how about now?
Yeah,
Good?
yeah, this is okay.
Perfect. All right, so everybody can see the bigger screen. Great, thank you. I'm trying to cover up a lot of stuff in a short time frame, and I'm going to have a demo as well. I'm just going to cover up the key points here so we can dive into the demo. So in the DevSecOps concept and mindset, and we need to build up a infrastructure, which is a pipeline, then we can deliver the product securely. So the security should be everywhere in our life cycle, everywhere, and in development and security operation. Let's move on. And when we look at the overall enterprise picture and how can we start, what we have to do, what are the things we should drive, it's really, we have to start from our business objectives, our business mission. What are we trying to achieve in a business? What is our goal? Because the purpose of DevOps and DevSecOps, it is not going fast and fail fast. Yes, we will go fast, but we have to arrange our cycles. We have to arrange our deliverables as impact to the mission. When we say the mission, why the Amazon building up so much fast? Because they would like to sell a lot of goodies in their website. Why Tesla wants to do fast? Because they would like to build up a high quality and very reliable and electric cars. So every organization has a mission they are trying to do. Then they're using the automation techniques, using the infrastructure to build up a product at the end of the day. So now taking the concept, it is based on the three concerns. We would like to build up our business mission, understand what are the goals that we are trying to achieve, what is the value that we are delivering our customer. Why is important when we say the delivery? Because typically in the security world, we never able to quantify the value of the security. Really, what that really means, like if we have any higher ups in our listener, they should probably understand better, because we don't able to say how much is going to cost to unknown vulnerabilities, which we don't know. We may see down the road, but how much money we will spend to build up the secure application? It's a very tough question because we don't know the value. So when we create a value and related with the security, the value will cover up the education of the people, infrastructures and technology, which is the investment. What we are getting out of investment, that we are delivering a secure product. Every product that we build, every product that we deliver, there is a security impact on it. Think about that. If your system is failed, how much money are you going to lose it? Think about that. If somebody compromises your data, how much money you have to pay your clients? Think about that. Your business maybe go out of business. There are many stories and related to the security which they compromised, they paid so much penalty. If you are in an organization, that organization is regulated by a government, like maybe a privacy act, maybe healthcare related, maybe a government. So we need to really monitor those based on the capability, which is a importance of the quantify the value. Then we are delivering the product at the end of the components. So there are 4 fundamental principles of DevOps, which we have to communicate and collaborate to build up that, which we are talking like this is the perfect opportunity for all of you. We are learning from each other. We are communicating. It's the same mindset when we are building a product. It is requiring to communicate each other. We cannot just say, hey, developer, here is the product you're going to build it for me. And then turn our head and go somewhere else. That's not working anymore. This is a waterfall mindset. We have to really work in a team to build up a feature, then deliver it to the client and get the feedback, and then build up the better version. One example, and Yusuke gave as well in the Tesla case, Tesla is successful because they are building a product directly for the users, and then they are monitoring, getting a feedback, building another car and another users, which is the driver. Every Tesla is a unique. It's so important to get the collect data, and then to build up that capability is requiring a really great communication collaboration. Then also infrastructure as a code is important. And we gave an example, and I'm going to give you more example in a shortly. So we are building the kind of like higher level communication collaboration aspect of it. When we lower in the level, we need the infrastructures. Like when we say infrastructures, it's about the laptop or desktop or the cloud environments. In this day and age, in this technology environment, maybe was very difficult 10, 15 years ago. Now it's very easy. We can write script for everything, honestly. We can write a script creating the virtual gateway. We can create a script to create a network peripherals in the virtual settings. We can create an infrastructures dedicated to the certain organizational unit and as well as product. On top of that, we can create a script. We can write the code. That code can start operating systems, can deploy the version, can configure the applications, and that can also the scale up and down based on the needs of the users. Because demand is really high. We are not responding 10 users anymore. We are talking about the millions of users. The human cannot do that type of operation anymore. It has to be written code. Now, third one is the automations. As I said at the beginning, if we are talking about the principles, if we are talking about the practice, if we cannot automate the deployment practices, if we cannot automate some testings, no matter what we have in our infrastructures, it is not successful. Because again, remember, we have to build up a high quality of softwares and product. How much we can build up high quality? We have to automate a lot of testing. Because remember, manual testing takes a lot of time and error prone. We have to automate those of testing, functional testing, performance testing, smoke testing. There are many type of testing can be automated. And we can combine those testing into our continuous integration practices, and we can deliver. The last element we should remember, we have to monitor our progress. How are we doing well? There's a two element of monitoring. We usually kind of monitor our operational environment to make sure that our product is working, it's supposed to be. But ideally, we have to monitor overall life cycle, overall, when I say overall, from beginning to end, from requirements all the way to the operations. We can monitor those evolvement, like how are we doing well, how much we are able to get it better, how much we can make sure that we are able to increase our deployment frequencies, how much we can do better and make sure that we are responding any outage, time to respond, time to recover, how much we are able to detect some mean time to recover. Let's say some systems fail, how much able to go detect those problems, how much quicker we are able to respond those incidents. DevOps is giving that capabilities for us. And if we put everything into the one big picture, there are three-dimensional thinking DevSecOps concept, which calls it maybe factory concept, but there is a people side of it. There's the engine pieces, like basically we are talking about engine pieces in the middle of the section. There are people are us. People is not just a developer, not just the security team, not just the operator, it's all together as a team. And we are doing automation every aspect of life cycle. Okay? That's overall DevSecOps that we combine all together. So let's move on. Now let's dive into the little bit infrastructure pieces. So when we building up any product, any softwares, almost every organizations, they should have at least the 4 main environments. So what it really means in an environment, like I'm a developers, I'm writing a code. This is my laptop. I'm using my laptop. Maybe I'm using my desktop in the back. This is my dev environment. That's what I build the code. I kind of write it. But think about that in an organization. You may have 100 developers. Every developer has its own environments. Now, every environment can be configured differently, which is bad. When we try to merge those code into the application context, because it's not that just one developer writes everything. There are many developers are contributing the component of the systems. That we're going to integrate those in an integration environment, which is the CI environments. So I write the code, then integrate in the continuous integration server. Then I continue to test those building as deployable artifacts in my staging environment. Staging environment will give me an ability to test those build artifacts before deploying to the production environment, which is kind of a minimalistically, we should have the 4 key environments. And how DevOps is really helping to solve the problem with those environments, we will be creating the infrastructure as a code. That infrastructure as a code will help us to keep the same environments. Like I'm a developer, I'm going to use same environment as Yusuke. He's going to have the same environment as me, so we have an environment parity. What really telling us here, I may configure differently in my environment. I have a Mac machine, and he may have a Windows machine. But when we look at application configuration aspect of it, you're probably using the same test environments. Like both of us, we are building a web applications, and both of us, we're using the same dependencies, same configuration of my dev environment as Yusuke. So we are eliminating a different version of configurations problems. A little bit history here, and then Yusuke kind of mentioned at the beginning as well. The biggest problem that DevOps was addressing about almost 2009 was addressing a problem between operational team, between the dev. The biggest problem operational team, they were not able to use the same configured environment as developers. Because developers are constantly changing, they are trying the new things, looking for the new libraries. We'll come back to the SPAM shortly. They were creating an environment for their own purpose. But operational team, they are supporting environment based on what they approved, based on what they know. There is a conflict in between. And DevOps mindset said, let's try to resolve this conflict by using the same configured script. To start, let's communicate first and be in the same page and then use the same configuration. So what that really means, like if we have an IT operation team, they might be using a specific Linux flavor. They may have a Red Hat version, maybe a CentOS, maybe Ubuntu. Let the developer has the same version of operating systems. Then how am I going to make sure that we are using the same version of operating systems? We are going to use a script. We are going to use the provisioning script. We are going to use the same script as been developed by the operations team. Now, when we talk about the security, we are going to use the same test cases, same infrastructure as a security team. It's going to give us a big support and solving the difference between various environments. That's how important, how really playing a key role in the behind the scene of building a high quality product. A little bit about SPAM, I knew we a little bit discussed before, and every configurations of this infrastructure is a code and has the module name, which is a component name. There is a version associated. So, which is kind of a giving me an ability to know what type of libraries I'm going to use, which version I'm using it, how I'm configuring those. So bill of material says, I need to know what type of components that I'm gathering to build up my applications. What are the components that I need to have they build up my operational production environment so I can get the parity those. Then using the format, I can exchange between the various, the kind of either vendor or the contractors, and exchanging those information. We don't want to share our code, but we can exchange information. My product is built based on this dependencies. The file format is basically CyclineDX or SPDX. There are two types of format will give us an ability. I'm going to show an example about the bill of materials, and in a format we can exchange informations between the contract, between organization units. Let's move on. So when we combine all these build steps, the continuous integration model is really giving us a build, kind of compile the code, or creating a package. And based on the package, and we will do certain testing. Maybe we can do the functional testing, we can do the performance testing, depends on what the purpose that we have building on a component. Then we can do the further testing based on the test result. Either we can put into the test harness to the further testing for a performance, maybe load testing we can do, or we can do a deployment directly into the production environment. So depends on the test result, we can do either a continuous delivery or we can do continuous deployment. Another things I have to mention here for the continuous integration concept, we are not just building code only. We need to think about other artifacts. It's really important. That's what DevOps is bringing again. You may say, yes, I have been doing a lot of build process so far. Nothing is new, seems to me. The new part of the continuous integration concept, it is not just building the code. So we have to think about other artifacts. What does artifacts means? Like, what are the dependencies I'm going to use in my production environment? Because application, it is not just application itself anymore. We have other configuration items, like operating systems, like some of the services, like microservices components, like dependencies. So I need to have a code along with my build artifacts, so I can package together and version those applications, including my configuration items, and then deploy into the production. Because if something happens, that's our assumption, if something happens in my production environment, how much I'm able to recover it from failure? It may be security failure, maybe a failure on operating system, maybe a failure on the disk, anything happen on the failure, any possibilities may happen. DevOps is bringing to be a resilient to failure those incidents, those problems. It's like using infrastructure code and along with other dependencies, and I can recap and I can use automatically and start up and do the business. Maybe I'm going to use the containerization concept and really scale up and down based on my needs. Let's continue. So as we said at the beginning, really we have to think about the security from inception, like from the beginning to the end. Every time we have to think about security. Why is it important? Because we need to quantify the security. We have to plan those security at the beginning. Like maybe we're doing some agile practice. Maybe we do the based on agile thinking, we might be using a Scrum or Scrumban or a Kanban or extreme programming or a SAFe. There are many agile techniques we might be using it. If you don't plan security requirements, if you don't plan accordingly based on the compliances, if you don't design applications securely, it is very hard to address security once we find out. Like Log4j specific example that happened in 2021, more than 75% of organizations, they were struggling to find out, do we have a Log4j or not? Very simple questions. Organization was looking for, do we have a Log4j? Like basic triage, they were failed to find out, do we have a Log4j? All right, if we have, are we using it? Which server has it? The next step is, which version do we have it? If we find out, so we are using XYZ server. Now, how can we deploy a new version without breaking other components? It became a problem because DevOps is a continuously checking, continuously planning, continuously adding those capabilities. It's at the beginning, like testings or integrating and designing. Information is the sharing. So we're kind of using this concept, adding a security baked in from the beginning. Any questions so far, Yusuke? I'm going to go to the next topic. Again, I really encourage to have discussions. Doesn't mean for me to cover up everything in the slide. I really prefer to have interaction because DevOps community means let's talk about it. Let's share information and be open, ask questions, and happy to respond those.
We didn't get the question yet, but everybody is just feel free to ask any questions.
Okay, I will do. So let's talk about the pipeline because I would like to make a demo of the pipeline. So I'm going to cover up what the pipeline means and have a separations and understanding the concept. So far we talk about more mindset changes, like what DevOps is doing it, what the capabilities. We may use the kind of continuous integration, continuous delivery. What is the secret behind those practice? So we call this a pipeline. Pipeline is an automated procedures that enable collaborations, managing risk, security, resilience, build and packaging, and deploying systems that we are building into the production environment. So kind of, it's like more about, it's our kitchen that we are cooking the food, as an example. We have a recipes, we are building many type of foods, but where are we cooking it? We need the tools, we need the infrastructures, we need a platform, we need some sort of a process. The pipeline will help us to build up a product securely from end to end. That's what the overall pipeline is. So, however, creating the pipeline, it's very, very, very challenging. Like when I say the pipeline, again, we're talking about the release configuration management, some tool, some scripts, server, different type test frameworks, different monitoring capabilities, maybe some source code, issue tracking. Which one are we going to use? What are the key characteristics that we will pick? Because there are many, many tools. And I put 180, actually it's more than 180 tools already available in the community. So how can we choose those right tools to architect our pipeline? We can go fast as a developers. And I usually give analogy is like a highways. If you build up a highway in a nice way, like put the right monitoring on top of it, put the right metrics, right gates, so people can drive their cars safely. It's the same analogy is also true for building up the right infrastructures, and our developers and our architect, our auditors, and our stakeholders can use this infrastructure as a pipeline effectively to support our business mission. So architecting this pipeline is very difficult and very complex. So what are we going to do? I have been saying what, but if we know the mindset, if we know what things is required for our purpose, it's becoming much easier. So usually, as an organizations, we always look at the tools. We are trying to use the same tools for everything. No, it's not right. Let's find out ourselves, what is my reason, what is my purpose, and I would like to build up those pipeline to meet my needs, which is more about like, what is my business mission, what I'm going to achieve. Like, who's going to own my pipeline? What are the things I'm going to measure it? How can I monitor those pipelines? What are the key quality attributes of the pipeline I can ask? Are we going to buy? Are we going to design? So these are the questions really we should ask ourselves so we can really build the right pipeline for our needs. Right? Let's open up a little bit more about the challenges in terms of what type of challenge we may see that. So there are a few challenges. One is how can we connect our process and practice and tools so our pipeline can serve effectively for our needs. So when you pick any tools to build up your pipeline, make sure that tool it's helping you to build up automation on top of it. Tools that we are picking, either issue tracking systems like a GitLab or a Jira, both has the issue tracking system, maybe other tools. Can we connect those tools? Can we automatically make sure that it is working by itself? Like think about the plug and play thinking. So we can really keep from end to end so we can build up our processes. So tool will become a solution for us. If the tools that you have, if it is not talking each other, it's very hard to build up automations. Okay? The second big challenge we may see, how I'm going to make sure that the infrastructure that are built is secure. Now we are talking about a different security aspect of it. One was building a secure application, which we have to do, like doing some certain security testings, some security functionalities, secure deployments. But also we have to make sure that we are protecting our pipeline with respect to security. Think about analogy, you are cooking a food in your kitchen. If somebody came to the kitchen, put some poisons into some of the food, no matter how much good quality food that you have, somebody already poisoned the kitchen. They don't need anything else. They were able to go to the kitchen, do something dirty stuff. It's the same concept. If I'm not able to protect my infrastructures and overall infrastructure on my overall pipeline for any type of insider threat, for any type of credentials, any type of spy, maybe zero days, many things. So I need to protect my environment. I need to protect my pipeline so I can build up a product software in my pipeline securely that I can do that. So we have to really think about that perspective. So really, we have to really apply the security concept into our pipeline. What are we going to do? Really, we have to really put some policy pieces. Who's checking the code? Who are the people who are accessing our infrastructure to push the code? We can use the two-factor authentication. We can use SSH. We can use the code sign-in. There are many techniques we have to think about that protect our code infrastructures. The same is true. What are the libraries that we are acquiring for our infrastructures that we can use? Maybe you can use open source libraries for building up your own pipeline. So we have to monitor those components, or at least we have a record of those components somewhere else. If something happens, we can go back and quickly respond those attacks, right? So let's move on. And a couple other things I would like to mention about the pipeline. And we said automations. And other things to have automations to make sure that our tools is able to integrate each other's. We're able to get the data from one to another tools. How can we build up the right monitoring in our infrastructures? We cannot look at every tool separately, building up and looking for different dashboards. In a typical software delivered environments, like we're really talking about maybe 10 to 15 minimum tools. If each tool has its own dashboard, yes, they have, but as a management perspective, do we have to go look at every different dashboards? No, I should be able to get data out of these infrastructures, and I can build up a common dashboard and see how I'm doing well. And to achieve this type of data, I should be able to look at those tools and look at their APIs. Is there any endpoint that I can use in tools and extract the data? Is there any way I can really connect the tools with other components? You may be able to connect the tools by configuring it, or you can connect the tools by using their API interface, writing a glue code to connect the dots, which is very, very important to make sure we are able to integrate and interoperate our infrastructures. Another things I should call out is about the availabilities. If something happens in our infrastructures, who's going to be handling those? If it is fails, who's going to respond those? Do we have a backup of these infrastructures? we often ignore, like we are thinking, I'm going to use the cloud environments and I make sure that everything is backed up. That's not true. Cloud companies, they're not responsible to back up your data. The same thing is true for the software. They're not responsible to back up your infrastructures or CI server. That's your job as an organization. Make sure that you're able to treat your infrastructure's backup and make sure you have a fail that happens, you have an error handling. Is it a database, web service? So make sure that the product that you choose has an ability to give you some log, some information about the failure of the product that we are using. It's just can give you an idea, right? So last things about the infrastructure, last two things. One is the scalability and performance. How much I can scale up my infrastructures. You may have 10 developers today, but you're so successful in organizations and your product will sell a lot, and suddenly you have 10,000 developers. What happens? Are you able to handle that load? You cannot really change your kitchen every time. It's very difficult. It may be easy for the food industry, but in a software world, it's very difficult because you have to shut down your infrastructures, get another one. It's becoming a challenge. So when you create those environments or selecting the tools, and make sure they are able to address some performance problem, you're able to address some peak loads, you're able to address some scaling abilities, like without changing interfaces, you may adding a new resources, make sure that your repository management is able to handle 10 users versus 1,000 or 10,000 users as a developers. Then most important, I keep saying it over and over and again, how much I can do the security testing integrations. Security testings cannot done by itself as an alone. We have to have an integration capabilities, every tools that we choose. Requirements, building and testings and designing every tool that you choose, ask, can I integrate security tools like SAST, static application security testing, or can I integrate DAST, dynamic application security testings? These are the tools we should integrate each other's in our capabilities. Then lastly, about the measurabilities. So we have to measure, as we said at the beginning, how much I can measure to this data. Can I collect those data? Can I put in an environment? Is it going to be owned by the tools? So these are the data we should collect and make sure that we are measuring the health of our pipeline. Because your pipeline has become your production environment and servicing your team, and people are using this DevSecOps environment, building up a product to you. It's challenging, but it's very important to address those. If we know the quality attributes of this pipeline, which I mentioned so far, scalability, performance, integrability, interoperability, these are the key quality attributes of the pipeline. We can architect those pipeline so we can and service our needs of the developers. Let's look at in general pictures. The pipeline as minimalistic way, as minimal. The pipeline should have a repository management, a source control in the middle. The source control is the source of truth. It is not just storing the code in our repositories. We have to store every artifacts along with the code. Artifacts are configuration items. Artifacts are maybe lesson learned. Artifacts can be specific to some infrastructure as a code script. It may be deployment scripts. So we really store those into the same repositories. It's important. Like as I said at the beginning, how can we make sure that I'm protecting my asset? This is my source of truth as the repository that I am building. Like as an example is the GitLab, one example, or the GitHub, or Perforce, many examples available for the source control. Then you should have issue tracking systems, which is the case. I'm writing a code about what? What is the purpose I'm writing a code? What is the reason I'm writing the code? It has to be initiated from issue tracking systems. The issue tracking the system will tell me, here is my backlog items, here is my end-to-end kind of my backlog items, here is my sprint, I'm working on it, I'm committing into the repositories, and goes into my source control. If I'm writing as features, I need to check those secret reasons. What is the purpose I'm writing the features? What the components are? What the build system looks like, as an example. Okay. Then automatically we have to build the code in infrastructure, which is we need a CI server. CI server, continuous integration server, is a system, and can be Jenkins, can be GitLab Runner, can be many other tools. Along with a couple other things, we have to communicate, like we have a communication systems, which is kind of a messaging. Like every developer likes to hear the message. Let the system is generating the message as a feedback. It may be Mattermost, maybe a Teams, maybe a Slack. These are the communication systems should be part of the environment. Two other things, like a monitoring system, I have to monitor everything. We cannot ignore the monitoring. Like you may have the Logstash, maybe you have other type of tools. You can monitor how are we doing well, how many builds we failed so far, how many builds we are successfully deployed, and who is accessing our infrastructures, who is changing our core source modules. Like a SolarWinds is a perfect example. The intruders were able to go and change one of the core authentication modules in the SolarWinds. They inserted malicious code on it, and people not get alerted. That's how we can do the for monitoring system to get alert based on what things are going in the infrastructure perspective. Then integration environment and code review are the key elements. So as I said, minimalistic, we should integrate all these tools, build up the general pipeline. As the one example, we can use like a Fogbox or Mercurial. Again, it doesn't matter what type of tools you're choosing it. Make sure that you're addressing integrabilities, you're addressing the communication, and keeping the source control repositories in the middle, which is going to be your source of truth for everything you do. Maybe you're hearing a lot of a concept of everything as a code. It's really putting every configurations, everything you write as a developer, architects, or the testers, store in a repositories. We can quickly take a look those for any incidents, so we can get information shared. We can relate to the diff, and we can do many other purpose as well. Okay. So what are we doing all these capabilities like pipeline? If you look at the typical scenarios as a human, we need to write less the repetitive work. We have to write more code, less repetitive work. Let the system handle the automated pieces. Let the system, the pipeline, handle the issue tracking system automatically goes to repositories and build it and test it and deploy it. Let the human, most expensive part is the human. If anybody goes in an organization, if you're going to go some business, if you're losing the money, what we do typically, we just cut the core, we just cut the employee cost because it's expensive. Now, as an organization owner, let's use our team members effectively in infrastructure. Why we are doing the same work over and over and over and again, which we can automate. Now we're using a DevOps infrastructures, automate all the rest of the manual stuff. Then human as the developers, as the resources and architect, they just can focus on writing a good quality of the software, including security. Another thing is really I have to tell you as a human management perspective, if organization does a lot of DevOps concept, they were able to educate their team members much better. They're able to spend the time much better because automated system is really handling all the big work behind the scene. It's performed by the autonomous systems, which is the CI server, CD, and all the component, which is the effect of the DevOps in the human life as an engineering life. Then we can get much more time, much more quality time, less stressful time as an engineer. We can focus on the good quality of the product. Right. So that said, I'm just going to stop here and then go back to the demo. I will come back to the slide again. Is there any questions so far?
Yeah, I think we have I want to pick a comment and also a question. Comment we got is about several comments, but good comments. But I want to pick a comment saying that he understood that those pipelines and resources prevailed in the infrastructure is the all connected under the concept of the this one. He understand that. And then this the way of thinking that the different processes would bring poison or vulnerability to stop them to prevail is going to be connected to the concept of the cyber kill chain also. He got a comment. I think it's
that's a good comment. Yes, that's a good one.
Yeah. And also I got a question. It's a mixed questions of two. So I will answer the first question is about, let me explain in Japanese. ですね。CI/CD の評
With
価に
respect to CI/CD's evaluation, the frequency of deployment could be one of the indices. However, when it comes to security patch or A/B testing, there are differences in terms of the meaning. So what do you think? From myself, well, according to my explanation, the higher of the frequency or the more of the deployment is better. Maybe that's how I explained during my presentation, but the best thing is on-demand basis. You can do it anytime you want. In the case of Google, well, maybe 40,000, 50,000 per day that you can do with Google. But as to the mega banks in Japan, for the updating software on demand, I don't think it would be once every 6 months. I don't think so. Utilizing megabank systems and to ask for the transfer of money or the authorize or give the authority, it's very difficult to understand. For the past 20 years, they use the same system. Just taking one glance, I know that immediately. People who are utilizing, I feel sorry. Since we have the security sense, usability is another spectrum. So we have to strike a good balance. When it comes to the on-demand, well, that is supply side. When supplier would like to change, then on-demand is used as a concept. However, what is users are asking as to the on-demand, where we have to think of the speed of development. The larger of the company, we need to be more mindful of a user side when it comes to on-demand concept.
And if I summarize that, he understood about how the CI/CD is convenient and give the speed up, but it maybe needs to think about also how CI/CD tool itself themselves would consume the computer resources, and it connects to the cost of the infrastructure. So how would his question is about, is there any best practices that optimizing such the resources of the computer resource consuming the computer resources and including the CI/CD tools and then the all things. Is there anything like that? The optimization with the.
It's a great question. Yes.
Whole infrastructure. Yeah.
Yes, there is absolutely possible. And instead of creating a completely VM infrastructures, we might be using some cloud services, a container base, and then we can scale up those components like a CI. So let's say GitLab Runner. GitLab Runner is a very resource intensive about the build. So instead of having many agents running, you can create your infrastructure, let the GitLab interfaces put many agents behind the scenes, so you can scale up when there is a need, and then if there is no need, you can scale down. So in the CI process, like continuous integration, let's go back to the continuous integration picture here. And if I am building the pipeline should depend on my tech stack. Like if I'm writing a C++ code, and I should have only an agent is running for C++. I don't need to set up many agents running as a parallel. Basically, you can orchestrate those agents and scale up and down, and orchestrators will manage those resources. So you can really separate those builds, and then you can initiate based on what the requirement looks like. We usually create a big giant service, and we are assuming that everybody's going to use the same service at the same time. No, it's not true. We need to create a pipeline. That pipeline will serve for our specific build process. And you may, behind the scene, you may use the containerizations for each of the components. If you are in a cloud environment, you can use the Kubernetes cluster on this environment. We can scale up and down. That's kind of architecting pieces in the backend. Remember, we said, how can I scale up my environment? Depends on the tools that you're using that's capable. If you pick some monolithical app as the tools, you cannot scale up that CI capabilities. It will ask you to create a completely dedicated server for you, like one Jenkins. You can configure, I'm going to make a demonstration for Jenkins shortly. You can configure the Jenkins in a single VM. You're just going to keep add more resources. That's a bad design. You should be able to create a Jenkins interface and create many other sub-projects in different agents, let the build server running in different infrastructures. Then you can dedicate it at different resources for each build. If we are setting up a SonarQube, which I have another example, SonarQube, you can put everything in a single VM, which you cannot scale up. However, you can get interface on one machine. You can put the database in another machine. You can address based on the needs. So that's what's kind of a typical architecture you can work behind the scene for resource management perspective. Are there any other questions? I'm just going to dive into the quick demo.
We have another question, which I think I can answer. In the example of the Log4j, he thinks that if there is this kind of those kind of solution are there, it's going to be very convenient, which is integrated with the CVE database, and give the users or engineers to give the alert that there's a new CVE and that kind of things. Is there any solution like that? And my answer is yes. There is. Oh, go ahead, Hasan. Go ahead. Yes, you are professional.
no problem, Yusuke. That goes back to the original question that we got about the SPAM. So the bill of materials should have the version of each libraries. There are many vulnerability management software. The vulnerability management software is basically asking, tell me what type of software that you have, and I can look at the CVEs and CWEs, or looking for the nation vulnerable databases or MITRE websites, or like a CVs and then CW website, look at the new findings. So that the vulnerability management software does that type of work. There are many tools available for vulnerability. What is important for us as an organization? We have to put the information in the vulnerability management database to list our tools, to list our dependencies. It is not operating system only. We have to look at all the dependencies. How can we look at all the dependencies? We have to have a software bill of materials. Like literally on the screen, this is one example of software bill of materials. Let me a little bit bigger. Here can everybody see? I am assuming. Let's make a little bit much bigger. So this is one example of the software bill of materials. Will tell me as kind of a machine readable format. It will tell me here is my organization as an organization as a name, and here is the tools that I'm using it, like using a specific component like Windows Embedded and using a publisher from Microsoft. Here's my version. I'm just going to scroll down, give another example. Like say I'm using a Tomcat Apache. Here's the version, and here's the package URL I'm downloading from a website, which is a supplier giving information to me. So I know the version, and then vulnerability management database, you look at the application name, look at the version, and then will tell me if there is a vulnerability or not. This is the basically bill of materials file. Give me a machine readable format for everything specific to my application, that application using operating systems, using in web server, using other components. This is one example as the cycling DX format. It's just basically the JSON format and on the workwise using an XML array. Any questions?
And if I add something, there's a tool also for open sources like Sonotype or Sneak provide such services that you can check the dependencies when you find out when there's a new CVE and for example log4j is infected and the users knows that the alert that you have to update this version of this you have to adapt this patch, but you have to also, when you update this patch, adapt this patch, you have to also update this version or something like that. Thinking about the dependency, but it's all about only scoping on the open sources, but you have to maintain your own source code. But there's a certain kind of the managing the secure open sources, such as like a Sonotype. Sonotype is used to be our sponsor in the last 2 years, and also they are funding for DevSecOps days also. So and also the Sneak provides a similar service also.
Yep. So great feedbacks. Let me go to my quick. Yep. This is my surprise to you, everyone. So I had the basic web applications. Do I have a correct one? It says welcome. Is that right?
Yes.
Okay, I made it. Right. So this is the basic web application, and I'm going to demonstrate and how the continuous integration is able to change the message. So this is the project, which is a Java project, and this infrastructure is running complete in AWS, using cloud environment, using AWS cloud, and using other services. And on AWS infrastructures, and I have a build server. Build server is a Jenkins, is my build, which is CI server. And also I have a repository management as a GitLab. This is my GitLab instance. All are using AWS. All the components you see here is basically using a container version of each of components. And I'm going to show the code as well. Before that, let me do a quick change on the message, and I would like to put another verb here. Maybe I'm going to remove, say the welcome. So let's translate welcome to DSO.
Would you make the screen bigger?
And yes, I think I can. Let's make it a little bit about now. So I'm just changing the message of the welcome. So I'm going to commit this, which is the code. That code is going to change the message on here. Just make to show you what a continuous delivery deployment means. So I'm just going to change, and system automatically compile the code based on the code that I change. Then do the security testing. I'm going to show the security testing shortly, which is my quality gates here. Then push into the production environments. Let me commit it and let the build is working behind the scene. In the meantime, and we will discuss and give more example for everyone. So let's take a look. All right, let's make it a smaller version of. All right. View. Okay. So I'm going to commit this one. Let's make it a little bit. When the screen is became big, so I'm not able to see every menu button. Hold on, give me 1 minute. So I'm going to create commit. All right, it's committing right now. Let's commit it one more time. Done. So that should be okay. Let's try to trigger the build. And I'm going to trigger the build now. All right. And that should start shortly. Okay, it is going to kick in. Let me refresh the screen. Okay, now it's started. So it is building right now. So while it is building, let me put the console output. It will do a couple of things. So let's go back to the while it is working. I'm going to go back to my screen and I'll give you some example of this code base. So we give the kind of infrastructure as a code. This is the one example what infrastructure means. This example is basically the provisioning tools. That provisioning tools is creating the VM and also creating the multiple components of infrastructure, like creating a Jenkins and creating an other type of component like a GitLab and creating the VM. This is one version of creating infrastructures, creating VM and creating the other pages like a wiki page, creating the many other components, staging. By the way, all this script is already available in the GitHub space. And I will share the URL. Yusuke, everybody can download it. They can experiment it by themselves. It's publicly available. So each of the script is configuring a machine. It is basically a VM, or it is creating a container version. The script does. Like as I said at the beginning, I might be using a VM. I might be using a container. So now this component is basically creating a container version of each of the components, doing the port forwarding and creating a VM. That VM has all the components. If you look at the Docker file here, Docker file says, I'm going to use a container version of Jenkins, and then I'm going to use the SonarQube container version and configure those volumes for each containers. So it's basically a script. Script does automatically all of the components to me, like creating a GitLab, creating components. Now, a little bit going back to our Vagrant file here, I'm going to show you a little bit more how the infrastructure and configuration management works together. In this example, like we are using, let's say, take a look for the configuration of the Jenkins. So Jenkins is using a Chef product. Chef is a configuration management, and using the cookbooks, which is the configuration manifestos of infrastructures. So when we look at our Chef cookbooks, if we look at the Jenkins, so basically we are pulling the configuration of Jenkins configuration recipes. In the recipes, we are creating what are the dependencies of my Jenkins that I'm going to use. As an example here, these are really a typical command line tools, which is a bash script. It is not a unique things we are talking about. It's a Ruby and using a bash script and creating a file. That file is going to be called by the chef and create a Jenkins, which is doing the yip, the RPM, yum install, and then RPM package, and download all the dependencies and running in the root, and also the configuring the Jenkins as well, starting Jenkins servers and connecting with the right SSH keys in it. That's kind of how behind the scene is working. So the demo that I had it running using the AWS version. So now you see the different version. In AWS, it's basically everything is created a template. This is the template that we are using behind the scene. That template is creating the bunch of virtual network, virtual private network, VPCs, and all the configurations. Everything is scripted, creating each of the protocols, IP addresses. As you can see, there are many components. I'm just going to put the kind of component right here. You will see more configured version, and using complete the container version of each of the libraries that you see on the screen. Like, let's take a look here. Like this one is, by the way, finished successfully, our Jenkins build. So Jenkins that you see on the screen is basically right here and using the container version of each of the components. So basically, I'm creating a container version as a EC2 service, like ECS service. That ECS service is creating the Fargate in AWS environment and creating the components to me as the container version. Okay, SonarCube is one of them. You see the SonarCube right here. SonarCube is the static analysis tools. So SonarCube is another container. All is done, configured as the CloudFormation template and creating my infrastructure from scratch. So I can really replica of these components depends on the resources. I may add more usage of memory. Maybe I can scale up. Maybe I can scale down. Maybe I can take the data out of it and tear down and just go to the cloud, the ECS instance, the container services, and I can kill all the services easily or delete it. This is basically AWS, which is a similar implementation you can do under Microsoft Azure platform using a resource manager as an example. Okay, this kind of a behind the scene, the code is kind of described us. So going back to the here, and I'm just going to give a couple of examples. The SonarCube is the static analysis tools. What it does, and analyze the code base based on known vulnerabilities. So in the SonarCube, I can set some quality gates. I can create a default one, or I can create another one. And based on the certain conditions, I can add a new condition, I can fail the build. This is kind of for the basic threshold. SonarCube look OS top 10 vulnerabilities, but I can restrict more, or I can really put the more constraints based on what security problems I might be looking for it. I can look at those, and also I can block the build as an example. So this is one way I may add many components. I added a code smell. I said if it is greater than 5 as a value, fail the build. So when I set as a default, when I build the next time, this will be a default and my build is failed, because pet cleaning is a web applications. There are some vulnerabilities, there are some bugs. So like, and there may be code smells. So code smell is kind of a potential problems in the code. You may see some vulnerabilities, you may see other components as well. This is a Java code. There is not much vulnerabilities in it, but this is automatically done. So let's look at the Jenkins right here. And this one is, we had back-to-back build actually. This one is successfully done. This one was failed, and because we kind of run back-to-back each other. So let's go back to the projects and look at this one. So this one successfully done as build, and we will look at the console output. And bottom of the screen, you see that Jenkins is really calling the SonarCube and get the result from the SonarCube. This is basically compiling the code. It's a Java code and packaging. I'm going to scroll down and tell you, and the packaging is done. When the packaging is done, sending data to the SonarCube. This is the analysis of SonarCube. You see that right here. It's basic analyzing all the code for a known vulnerabilities in the code base. So the Jenkins is calling the SonarCube for static analysis testing. When it is done, getting the result back and says it is successfully, execution is done, and we got the result, it's good. The next step is right here, and get the artifacts artifacts is the jar file of the Java projects, and putting into the AWS deploy. This is the place for the deployments, and automatically will deploy into the AWS production instance. This is our production instance. Let's try to refresh. As you can see, we changed the welcome from Japanese back to the English as a welcome. This is a basic demonstration of how the automation is triggered automatically from a build server as a Jenkins as a build server, then how the security testing is done, then push into the deployment environment. The Yusuke mentioned the one product, which is the Nexus repository, which is a Sonatype product. What it does, it's basically getting artifacts, including the third-party tools that I might be using it, and including other capabilities. I can make sure that my pet clinic war file that I created, it's securely put in this environment, and I can use a secure file deployment from my repositories and goes back to my deployment environment. This is more about Artifactory for managing the repositories. So there are two repositories you see on the screen. One is the source code repository, which is a GitLab. The other one is the binary repositories, which is the Nexus. Again, you're going to create one code repositories. The other one is your libraries and artifact. The automatically machine will do behind the scene. And behind the scene is basically creating artifacts, pulling the code from repositories, automatically building, automatically testing, automatically putting the repositories, and then deploying to the production environment. That is a simple, a continuous integration, continuous delivery from end-to-end perspective. Again, all these code pieces is available for you guys can download it, you can play around, you can test for yourself, you can set up your infrastructure, and everything is available and under SCI and GitHub space is publicly available. Any questions so far? I know I'm running out of time because I have a class in 10 minutes. I have to go. Let me go back to my slides and say a few words so we can really close my sessions. Okay, it's coming up.
From my side, let me ask
Sure.
practical question. For example, as an engineer, when he build a new system or software, and then the shorter way or easiest way is to find some open source or which can be built and then leverage it to develop a new system or service. But before using it, what do you have to think about its safety, or maybe the how vulnerable it is, or what are the code of conduct there?
So
they should think.
My short advice is we have to think about that every code can be vulnerable one day, one time. We don't know when, but we should have an assumption. As a developer, as an engineer, we have to record in a machine-readable format what language I'm using it, what is my libraries, what is components. If we cannot create as an example of the CycloneDX XML I presented, you may create just a text file. It doesn't matter, it has to be formatted, just record it. We don't remember what we wrote it, what the components are. We often forget because we just write in the code. That's basically a habit. As an engineers, open up the notepad, put your libraries, put your frameworks, put your versions. When you put those information, you may be writing a script. The script will keep that information. So my assumption is everything will be breakable one day. We don't know when. The question is how much we're ready for respond those type of vulnerabilities down the road. To do that, we have to record somewhere else of these libraries.
Okay, so like DoD, they try to control the which the source file can be used as a repository. They put
correct.
Yeah. So that's what the DoD has transformed. They can't use whatever they want, but somebody checks and then
Yes.
checks and all the source, the source of the containers and then the different open sources. This is a safe one, and you can use it freely. So those kind of, how do I say, operational infra is also important for larger organization.
Yep. That's basically goes my last one, the platform. So we're going to make sure that we are using the secure environments, we are using the security infrastructures, we are talking with the security teams. As a developers, we should not copy anything from Stack Overflow, putting in our infrastructures. We cannot trust any type of libraries that we are downloading from internet. Somebody may change that. So we have to really find out the original source of as a package URL from direct vendors. Like, don't download any container files from Docker Hub. Docker Hub has a lot of vulnerabilities in it. Try to build up your own internal registry and organization, analyze those container files, make sure that it's not vulnerable code in it. That's what the DoD does a lot. DoD, and I have been helping for them, we are building a lot of container version of components, and rest of the DoD folks can use the safe version of those components. At this, we know where we are getting from. At this, we are getting information, what is really constructing, what is the component behind the scenes. So last things, and everything is code. So this is the URL, and people can look at more information from the CME SCI website. I have been doing a lot of webcasts and podcasts and webinars. Actually, I did the podcast today. It's available on the YouTube. And if you guys have any information, you can reach out to me or Yusuke every time, and I'm happy to discuss and answer more questions.
Yes. So you have to jump off now?
Yes, I have to go because I have only 4 minutes. I have maybe 1 or 2 minutes. Apologizing, Yusuke. My class is going to start in 4 minutes.
Okay.
Apologizing. But and definitely we can continue our discussions again and maybe set up another time and then for follow-on questions. And if there is any more questions on the YouTube, and maybe we can answer some of them tomorrow.
Yeah, he is coming up tomorrow also. So let's take questions also tomorrow.
Great.
So lastly, do you have anything to say that DevSecOps haiku or DevSecOps whatever poem or something?
My biggest word is don't stop, keep learning. Please share your stories, ask from others. You're not alone by yourself. You're not just one independent person. Somebody somewhere else are doing the similar things. Nothing is wrong to ask. Please ask. Let's try to learn. And there are a lot of people are willing to help, which is I'm one of them. As you said, you've got a lot of volunteer people and try to exchange and share information. This is the purpose of DevSecOps community. We are trying to exchange information. I have been teaching courses last 6-7 years at the CMU. I see a trend. It is real. It is getting a lot of effectiveness. A lot of people likes to use. Let's share, let's learn. And again, I'm happy to answer those questions anytime.
Yes, and also we are expecting the audience to share their experiences next year or as a speaker. So that's what we want to do. So that's why we've been speaking. Sorry, I'm speaking in Japanese.
Okay.
3年ほどやってきましたけれども。
So it's been 3 years now, and this is a third year. And next year, this similar, the same setup. From this audience, we'd like to have a speaker from the audience to share his or her experience. So, and we need to say goodbye to Yasar, to his class. Thank you very much.
Thank you. See you tomorrow.
See you tomorrow. Bye bye.
Bye.
はい。ということで、ありがとうございました。ハサンさんの長い、1時間今日の、講演とデモでしたけど、まあ、雰囲気分かりましたよね。
So, thank you very much. It's been more than 1 hour, but I think you got the flavor. And the manual work need to be eliminated. And the code writing, it remains to be manual, but the people are writing codes, and those code writings should be more secure and should be reused and should be faster in deploying to the production environment. That's engineers and for users to use them purpose. And when it comes to DoD, so it's something like a software factory. So the illustration, these resources are safe, and this language, this version, these frameworks are safe. That's what we can see. And hundreds of containers. And it's those containers, a group of containers you can use freely. You don't need to create them from scratch. So that's how we should move forward. And software development, we should save labor and also should be simplified. And that's what we should continue. And in a software environment in the US and in Japan, the evolution, I think there were lots to learn for Japan. Now I'd like to take a 10-minute break. And from 11:10 past, we'd like to resume. And after the break, we will hear from Dr. Tomabechi. Now it is 11:01, so we will resume the session at 11:15. So please stay tuned to watch the sponsors' information. Thank you.
DevSecOps Days 東京は DevSecOps を推進するためのコミュニティ活動に賛同してくださる多くの企業・団体から支援を受けています。プラチナスポンサー NTT データ、ブレインパッド、コグニティブリサーチラボ、ゴールドスポンサー NRI セキュアテクノロジーズ、GMO サイバーセキュリティ by イエラエ、シルバースポンサー HRD プロファイルズ、スタートアップスポンサーロバストインテリジェンス、リチェルカセキュリティ、講演アメリカ大使館、経済産業省、総務省、文部科学省、デジタル庁、サイバーセキュリティ戦略本部、カーネギーメロン大学ソフトウェアエンジニアリングインスティテュート、カーネギーメロン大学サイラボ、コグニティブ CTF、世界から届いた食材が彩るディナーテーブル。約束の場所に時間通り安全に到着する交通機関。どこでも安心して受けられる医療や薬。遠く離れて暮らす家族に贈る誕生日のプレゼント。その日常は人や物をつなぐ仕組みで支えられている。お客様と社会と、そして世界中に広がる仲間と共に新しい仕組みを作りつないできた。世界は常に変化を続け、時には想像もしなかった困難を私たちに突きつける。必要なのは何ができるかではなく、何をすべきか。社会があるべき姿とは何か。次の世代にも続く本当に豊かな暮らしとは何か。それを見つめ、私たちは行動する。NTT データ。
ビッグデータや AI 技術が脚光を浴びるデータの時代がやってきた。巨大企業もベンチャー企業もデータを大きな経営資源と捉え、ビジネスに取り入れようとしています。15年以上前からデータ活用の可能性をまっすぐに信じてきた私たち。今こそ一緒にデジタルトランスフォーメーションで開けるドアがたくさんあると思うのです。
持続可能な未来につながる扉。
成長し続ける。
できること、広がる。データ分析の民主化。
最適な意思決定。
挑戦できる未来。
ささやかな幸せにあふれた日常。
成長です。
ときめく。
顧客体験を磨き続ける世界。
豊かな社会。
意味のある仕事を作る。
誰もがビジョンにチャレンジできる。
誰も想像できない
大きな成功。
イントゥリアンノン。
目から鱗の瞬間を提供する。
製造の無人化。子どもたちの未来。
データ×ワクワクイコール未来。
できたらいいなを形に。
仲間の笑顔が未来の笑顔を作る。
未来は作るものだというふうに考えているので、仕事を通じて新しい価値をですね、創造すればですね、日本がまだまだですね、成長できる、面白い機会を作ることができると思っているので、かなり広範囲のビジネスをですね、僕らはご支援できるんじゃないかなというふうに思っています。
その意志が世界を守る。テクノロジーは常に進化する。インターネットが人々の間に広く普及し始めてから、様々な技術が加速度的に進化し、派生し、広がった。気がつけば、私たちの暮らしは便利さという名の下で大きく様変わりしてきた。テクノロジーをどう使うか、それはその人間自身に委ねられる。人はいつの時代も人が作り出した矛盾にとらわれている。善か悪か、勝つか負けるか、傷つけるのか、守り抜くのか、そのパラドックスに常に挑んでいる。今やビジネスだけではなく、日常生活においても IT の力が不可欠になり、全てがネットワークでつながる時代。24時間365日、社会全体が常に IT の引き起こすリスクと向き合わなければならない。時代の変化を見極め、新たな知識を蓄え、培ってきた技術と経験によって決して負けられない戦いに挑み続けていく。恐れずに進もう。あなたの揺るぎない意志がこれからの時代を守っていく。その仕事で人類の豊かさを確かなものにしていくんだ。さあ、プロフェッショナルとしての誇りを胸に、この社会を前進させていこう。その意志が世界を守る。 NRI セキュアテクノロジーズ。
コグニティブ CTF は誰でも楽しくセキュリティを考慮したプログラミングが学べるゲーミフィケーションプラットフォームです。すでにソフトウェアエンジニアとして活躍している方も、プログラミングに興味のある中学生、高校生、大学生でもどなたでもゲーム感覚でお楽しみいただけます。コグニティブ CTF は政府機関の研究開発プロジェクトとしてコグニティブリサーチラボと東京大学、京都大学が共同開発しました。軍事大国の現役サイバー兵士が取り組むような難易度の高いものから、初めてプログラミングを学ぶ中高生の初心者の方でも楽しめるものまで、多様な問題を取り揃えています。コグニティブ CTF に取り組むことで、基本的なコーディングスキル、暗号解読、フォレンジクス、リバースエンジニアリング、バイナリ解析などに関する問題を解きながら、ハッカーとしてのスキルを向上することができます。悪意を持ったハッカーがどのように攻撃してくるかについての知識がなければ、ソフトウェアの安全と安心を保つことはできません。現代は あらゆるソフトウェア開発者にハッカーとしてのスキル習得が必要になっているのです。ぜひあなたも一度、コグニティブ CTF でハッカーとしての腕前を試して楽しくスキルアップしてみませんか？ QR コードを読み取ってぜひ参加登録をお願いします。どなたでも無料でお楽しみいただけます。
インターネットの発展は私たちの生活を便利に豊かに変えました。今では水やガス、電気と同じくらい生活に欠かせない重要なインフラです。会社や学校、病院、銀行や工場、ありとあらゆる場所とシステムがインターネットにつながっています。そんなインターネットがサイバー攻撃の脅威にさらされているなんてあってはならないと私たちは考えます。私たちはサイバー攻撃で使われる脆弱性や攻撃手法を日々研究しています。その結果、なんと直近1年間で約30件のゼロデイの脆弱性を発見しました。私たちは悪意あるハッカーが攻撃するよりもずっと前にお客様のシステムのセキュリティホールを見つけてご報告します。私たちはこれまで先進的なセキュリティ技術を研究し、知識を共有してきました。私たちはこれからも企業とシステムを利用する全ての人をサイバー攻撃から守ります。目に見えない脅威から暮らしを守る、日本を守る。全ての人に安心と安全なインターネット。
HRD グループは科学的なアプローチで人事や組織の改革を強力に支援しています。今、多くの企業がデジタルトランスフォーメーションに取り組んでいるのではないでしょうか。デジタルテクノロジーを活用することにより、営業やマーケティングの見直し、業務プロセスの自動化がさまざまな企業で実現されています。では、人材や組織に関してはどうでしょう。一人一人の才能や個性に合わせた適材適所の実現や効果的なコミュニケーションの実践は、デジタル化とは無縁の勘と経験に頼っているのが現状ではないでしょうか。このような勘と経験に頼ってきた人事や組織の課題もデータにより解決する時代になってきています。私たちの提供するディスクとプロファイル XT は科学的検証に裏打ちされた人材測定ツールです。一人一人のモチベーションの源泉やそのポテンシャルを見出すことで組織や人材の課題を解決します。全世界でこれまでに6000万人、10万社、日本でもこれまで120万人以上の顧客が効果を実感しているソリューションです。これからのデジタル時代の企業における改革の本質は、人と組織のトランスフォーメーションにあると私たちは考えています。HRD グループのディスクとプロファイル XT が組織や人材の改革を可能にします。効果的なコミュニケーションによる組織力向上に興味のある方はディスクで、社内の適材適所の実現や人材のポテンシャルを見出すことに興味のある方はプロファイル XT で検索して、ぜひ一度ホームページからお問い合わせください。DevSecOps Days 東京は DevSecOps を推進するためのコミュニティ活動に賛同してくださる多くの企業・団体から支援を受けています。プラチナスポンサー NTT データ、ブレインパッド、コグニティブリサーチラボ、ゴールドスポンサー NRI セキュアテクノロジーズ、 GMO サイバーセキュリティ by イエラエ、シルバースポンサー HRD、 プロファイルズ、スタートアップスポンサーロバストインテリジェンス、リチェルカセキュリティ、講演アメリカ大使館、経済産業省、総務省、文部科学省、デジタル庁、サイバーセキュリティ戦略本部、カーネギーメロン大学ソフトウェアエンジニアリングインスティテュート、カーネギーメロン大学 サイラボコグニティブ CTF。 世界から届いた食材が彩るディナーテーブル。約束の場所に時間通り安全に到着する交通機関。どこでも安心して受けられる医療や薬。遠く離れて暮らす家族に贈る誕生日のプレゼント。その日常は人や物をつなぐ仕組みで支えられている。お客様と社会と、そして世界中に広がる仲間と。
はい、ではですね、休憩終わりということで。
I'd like to close the break. Have you watched Hasan's videos? Thank you for waiting. Next, we'd like to invite Dr. Tomabechi Hideo. Is the development progress and the possibility for the future. We would like to ask Mr. Tomabechi to cover the session. This is the last session. Some people, or I do believe many people are very much looking forward to watching Mr. Tomabechi's speech or listening to his speech. Welcome to the DevSecOps. This is the third year. We started the DevSecOps before COVID-19. Well, we were hit by COVID-19, and we have invited every year very high-profile people. And in the US and Japan, well, not DevSecOps done, and we have designated the DevSecOps evangelist, and the Pentagon is also supporting. I do believe that it is moving on track. And Mr. Nishira has been operating DevSecOps in Japan and prevailed this event. This is the material of a digital agency. And can you see? Maybe I should change the background color. So this is the deck from the digital agency. Maybe you don't have to see this. So according to the material, it describes security by design, implementing security measures, including DevSecOps. So in the documentation of a digital agency of 2020, the word of DevSecOps was covered. It's amazing. The digital agency is the center, and they say we shall do that Japan could transform as an advanced country of DevSecOps all of a sudden. Also, the JFSA mentions resilience in its documentation. But when it comes to resilience, the Pentagon is the one to spread the important word of resilience the most. And they have created stories. So the central government has started to mention resilience as a user rather than as a system. Thank you for your efforts. And also, owing to our evangelist, Nishihara-san, whose efforts contributed to this. Congratulations. Now, lectures are available. And some professors participated at this event before it actually became a DevSecOps, which we continuously running as an important matter. This initiative was carried out in cooperation with the Pentagon. From that viewpoint, we have videos on DevSecOps covering the last 3 years. So again, the 3-year period of the videos are available. I believe I don't need to talk in detail. Having said that, why now DevSecOps is taken up and how it is developed moving forward. This is something I would like you to learn. the base of course, this concept of DevOps is underlining. DevOps is done by the DevOps Tokyo, and Google has worked on this thoroughly. Therefore, it boils down DevOps when it comes to DevSecOps. So it does not because that the DevSecOps was created just because security aspect was added to DevOps. The concept of DevOps per se has a robust security model from the start. That is the philosophy in place with DevOps. With that in mind, at each stage, cybersecurity, especially Carnegie Mellon University, says cybersecurity and primacy. So cybersecurity and primacy will be an important element moving forward. But first, the security. Well, if destroyed, the game is over. Let me again look into the deck of the digital agency where DevSecOps word was covered. Maybe it was not the digital agency, but the JFSA deck. So according to the JFSA's documentation, it says that the measures during peacetime and the measures in the event of emergency and contingency. JFSA says that taking measures by separating in those times under peace and crisis. Measures during peacetime is to capture information asset and take actions against risks. And for emergency cases, formulate a contingency plan, participate in joint exercises and trainings. The JFSA will participate in the joint exercises. It's amazing. So they say resilience too, including the JFSA. The digital agency does not use the word contingency emergency intentionally as a jurisdictional authority, maybe, as the digital agency is not a military body. That's intentionally they don't mention that word, but in essence it is the same. But thus, the concept of the contingency emergency has started to prevail in Japan. Well, the JFSA says contingency. Well, currently, economic sanctions are used as one of the weapons of war. And if something happens in Japan or surrounding Japan, a destructive act on financial world is naturally expected. So what is the typical attack on financial world is cyber attack. Therefore, the JFSA uses the word contingency, emergency naturally. From that point of view, the security is something very fundamental, and it is a core. So current days are completely different from those days that you say that you implemented the antivirus software, so it is okay. Experts of DevSecOps have discussed this. So audiences have joined this event for the second and third time. Therefore, you have a good knowledge of this. So I have reflected and thought over the logic of DevSecOps. That is the system, including some specific engineering or some specific software engineering. And now it is combined with AI before anyone knows. So it has become DevOps and DevSecOps. So on the contrary, all the software developments are based on DevSecOps, and now we need to take into consideration of a contingency and emergency. Under such circumstances, we need to think cybersecurity beyond what we have assumed so far at each stage more seriously under primacy. So understanding DevSecOps. So let's look back the flow. So originally, when it comes to system, and of course, it is a type of software engineering, SME, SEI type of aspect is ahead of this stage. So when it comes to the system in general, first stage is system design. Based on that, it is built, and the very basic architecture does not change easily. And that's true. For example, when you're making a building, you change the foundation a little bit, or after it is built, you change the foundation, you would not accept. A foundation is created, and then on top of that, things are built. If you think of computer science, the base or foundation is chips. But what comes first? Well, risk comes first, but first is the Lisp, an idea of so-called virtual machine was emerged. In the case of Java, it is really virtual machine, but in the case of Lisp, we don't call virtual machine. It is a core engine, and if you know the Lisp concept, then you call it a lambda abstract. It is a lambda machine. It is a sort of a prologue machine or pure lambda machine. So each is a Lisp machine. But the basic architecture of AI in 1980s, it is so-called the lambda machine in the Lisp world, likewise a prologue. So from the start, it is a sort of running a virtual machine that is a basic premise, and it is the AI's world. But as represented by Lisp, the data size is infinite from the start. So what is the X bit? That is not available. For example, what is the size? But for this, it is an infinite size. In case of AI, no specs can't be determined or fixed. So from hardware rules to be separated, or that needs to be separated from hardware rules. The language like Lisp is lambda abstract.
So in the so-called computer science manner, it's the first order predicate logics function. As a matter of a computer science, the function of the predicate logic becomes a parameter of next function. So in terms of a numeric value, but the function becomes a parameter of a next function for the first order and then to next order. So in that sense, you need a lambda abstraction. And in mathematically, for the round abstraction, you need a dedicated machine. Of course, you can make with a software, but the Lisp runtime and WAM. So those abstraction machine. And as a model, it was already developed in 1950s or 1960s, but it became generic with the development of AI and the system context or software engineering robustness. It's the foundation is strong. You have chips and then operating system on top, and then middleware and application. So Unix model, Linux model, and the successful OS. I was a part of the project back then at the Carnegie Mellon, Unix type of OS. And next computer employed and Steve Jobs when he was fired by Apple. The next computer employed and then Steve Jobs back to Apple and Mac architecture. And Windows from the time of NT. Now they started Mac architecture and currently it's Mac architecture. And evidence is a concept of threat. So Mac typically uses thread, which is light. So semaphore, you may know the concept semaphore for the heavy OS and shared type of memory and transcendent type, which is much lighter than those. But that's the type of thread architecture. And the Linux is now using Thread, and Apple, Mac OS, and Windows as well. 80s Mac architecture is our basis. And that logic is about the chip at the base and a decent OS and middleware and application. So from bottom to top type of construction, and roles are divided. So in developing sizable system, their OS, they don't play with OS or chips. They are higher level architect or designer, and then other parties build. So it is like a construction company. The contractor and builders and the prime vendors get the project, and then they use an outsource or consign the smaller projects to subcontractors. So they may select OS or chip, but they do not make chip or even a middleware. From the computer scientist perspective, end users. So as a sense, they're end users. As a trend, the system is created, and with the division of roles, the bigger systems are constructed. And speaking of AI, well, in terms of the trend, Japanese prime vendors are still abiding by the waterfall scheme. But speaking of AI side of people, they need to do everything by themselves. In designing and making the AI, now the deep learning is the basics. The graphic chips is something that they prefer. The second chip in the beginning of 1990s, we purchased 2 units of those machines at 100 million or 200 million. That's a recurrent type and audio recognition. And the current machines, it is much faster, 100 million times or 10 billion times faster. Those gigantic digital space and smallest error algorithm, those hardwares are specialized in those features. But at any rate, for whole AI, what sort of a processing model that need to be considered, and based on that, machines and OS are designed and built. What's most important is the very foundation. That's what you need to replace. So you don't need to replace the chips, but changing the virtual machine designs. Back then, IBM executive called me, and he scolded me if I was an IBM person. I remember I got scolded. I don't exactly remember why. And we were working on the chip design and the compiler, and we were making OS. And of course, we were doing middleware. And he scolded, are you really IBM? But the US IBM has been supporting greatly. So I owe a lot to them. But people in AI need to do everything. And the specification changes over and over because of the programming. The human thinking process is what we are dealing with. There's no specification. So if we could have a specification, we can elucidate the mystery of human being, because human thinking has not been elucidated yet. As a result, humane things we want to enable. It's about the soft AI. Recently, that's what we say. But we say like a hard AI and a soft AI, but the human-like output should be realized, and the current deep learning is doing really good. But in a middle layer, some time of a cluster analysis is conducted. We have some kind of a chunk. In the symbolic or sub-symbolic manner, now many people are trying to use it some way using deep learning. But the AI people doing the programming of various networking, the intellectual language processing in the neural network started doing it in an automated manner. So what can be made? We have to try. What can we make? We don't know, because current deep learning in a DevSecOps team, I think it is included that probably tens of billions or the 30 billions. So it's not that cheap. I'm talking about serious deep learning. It's like the vehicle driving. Because we are handling super fast machines. So one network tuning, it is not billion or 2 billion. It is hundreds of billions.
And of course, such a network will be used by others, and that mechanism could be needed. However, from now on, deep learning could be in trillion value. So that would be the sizable cost. Maybe e-learning network with Samsung, if you were to take it for 2 weeks, you can't acquire. Maybe the in 1980s, Silicon Graphic, when you use the two of them, one unit takes 100 million to 100 million yen. So now it is the usual that it costs 100 billion to 100 billion. You are doing is investing in more money than 100 billion or 200 billion yen to use the result of a tuning network. Some people provide this free of charge. The source of such money was initially coming from government's funding or such rich individual comparable to Google, for instance, to contribute money. Maybe you are utilizing network that is kept under wraps or black boxing, so the lots of money is incurred. Such network that cost outrageous cost is brought elsewhere, but may be tampered by malware. For example, people engaged in AI, deep learning, and such studying for cybersecurity purpose. Maybe some of you in charge are involved in here. In any case, the gigantic system is built. During that process, as a result of those processes, you make up incurring 300 billion yen, then maybe this eighth layer, or this is a block we found, according to the past Google, or they found some images of monkey's face. So as long as you, when you understand, recognize the network of the concept, maybe you think that that concept is something wrong, or maybe it could be utilized, or when you find that, you do not do any retuning of the network. Of course, you use it, but combining with that network, you'll be able to think of different options. Now, from a static perspective, machine it's by itself will learn something. So that is the machine learning, but in the past, something that is working on more conceptual side, there are different types of usage, whatever the approach you take. When results are generated for the first time while processing, overall design is recreated, and it is a norm for AI. Human beings are not figured out yet, and we are creating machines, and what is needed as a computer, we use the machines, and we have to do the massively parallel processing, and this is something that human beings can do, and machine architecture shall do also this MPP while creating this. Maybe you could purchase chip or OS, of course, it is rewritten, and middleware too. However, from the original system engineering logic perspective, it is out of alignment and off. So therefore, how it is to be used for the flow of DevOps or DevSecOps. So this is the flow or trend of DevSecOps. But from system perspective, so terminology is different for what terminology used for people involved in AI are different slightly. So, however, it is now converging. For example, if we were to bring one notch up from the abstract perspective, then in the degree of abstract, it is a separation from hardware or physical space. The layers, there are multiple layers in between. So if DoD uses Google, well, Google provided the best product. Therefore, the Google layer is used as the middle layer. However, the upper layer, that is the abstract layer, maybe it is the same in essence as to the iPhone produced in China. So therefore, JFSA say that the foreign companies, if you were to use the Google AWS, maybe it would be difficult, but they say AWS of Google is very secure. But in any case, Google AWS, why the digital agency is utilizing foreign-made things? That is not the case. When you use the Windows, now it is turned into Lenovo from IBM. Or I like LG, so I use LG. And Fujitsu bought LG. Well, whatever the hardware is, it does not matter. Likewise, in the framework of platform, they shall be separated from the abstract perspective. Now it is becoming a security model. For what we have to do is those people who are involved in AI, it is no surprise. It is a fetch type Neumann architecture that we have, but it is not a Neumann architecture, but the human beings' way of thinking needs to be mimicked, but the only Neumann architecture could do that. Therefore, thinking about the Neumann architecture or the MPP, massively parallel processing, or maybe Prolog or Warren's abstract machines, or maybe running Lambda machines at the abstract layer on top of the chip. Another virtual machine is set up again on top of that. Another layer. For example, if you are to use the object, then in the case of LIPS, it is the object system. Well, object system or first-class object, whether or not that is the case. If we were to discuss over this, maybe it is incomprehensive for those younger people. But in any case, that has generated the current microservice. And of course, from a system concept perspective, microservice is available. However, automatically it should be embedded. Well, because it was now available to activate mass thread from NPP perspective. I don't know if you know this Linux. The launch thread, maybe 25 or 30 per CPI that could be activated. Therefore, you have lots of the circuit boards. Now we are entering into the 21st century, and you have a series and the number of circuit boards lined up. And what we do is just a get and post, and then you have lots of circuit boards, and this is something that Linux is still doing. And it is a markup architecture that it is done. So per CPU, maybe 30 or so. Maybe if you were to have the several CPUs, communication-wise, that's not much in change. So I don't think that it will be piled up to the 5 billion or so. So now what is connected in a space that is on a cloud basis? The cloud space is that Google or Amazon, well, it does not matter, but you'll be able to separate that space. And whatever the CPU, maybe it is the other side of the network of CPU. but you can use. But how can you do the deal with the mass thread? Now you are just building up the number of circuit boards. But in any case, 1,000 thread could be built up. Well, that is something I have been actually designing. So it looks like a digression of the topic. However, this talks about the essence. So from the physical space and separation in a processing space. Maybe in a case 10 microservices will be used only one process, or 10 again. Only one processor could deal with the 10 microservices. So it is only abstract separation, and mass microservices are used, and that is used as object-oriented. So object-oriented is the base. For the psychology, we used to have the cognitive science, and that was the psychology from the behavioristic type. And then it is the developmental psychology and clinical psychology. So one of them is the cognitive science. But everything is under the cognitive science, where the education, developmental psychology are falling into. So it's all object architecture. We don't have to say object. When you learn program language for the first time, it is object language without any fail. But in the past, we did not have that language. Therefore, we only had the object language. That is a data capsulation. So this encapsulation combined with the data, integrated with data. However, at the time of DevOps, that is the basic. Therefore, it is the space separated with the abstract. And also this separation of the abstract without your knowledge, it is at the layer of OS and middle layer. CPU, CPU resources and memory resources will be dynamically applied. And data block is a capsule with data. Well, currently we don't call as capsule, but container. And I still use the word since the start of the Windows. So it's a container. So in any case, so while you are developing, you will think ahead. It is a more of AI type of the idea. Maybe while you are creating a system, maybe we have reached to that point.
So, well, genius creating doing everything from scratch in designing, that's not possible because they are not profit. And while making it, the specification keeps changing. And the prime vendor divides the role. That's not the case. But a huge amount of microservices, each small teams or units make microservices. So forget about CPU. So let's say I'm in charge of this microservice, and it may be used or not used. We don't know. So DevSecOps thinking and the concept of time is introduced in the DevSecOps. So the original AI developers, what they used to do, we haven't elucidated the intelligence, human intelligence. So of course, it is a trial and errors. So that type of paradigm, the software not having AI is now much smaller. Regardless of a size or scale of a software, the need is increasing, and it may be too rude to say that everything was done inside the Carnegie Mellon, but in a broad sense, AI was also handled, studied as a part of a computer science. And SEI, that's a very special, gigantic institute operate with a DoD funding. And you can look at the faculty member, there are some overlaps. So naturally, it was constructed. And DevSecOps is now integrated and practiced as a part of it. And this runtime logic. The abstraction is separated, and by capsules, the security model is introduced. So, of course, that model is already included. But on top of that, in details, the security is all the time in all levels. The security is embedded, and DoD, US DoD, has employed to this day. And what's good about Japan? There's no process in between, but start using DevSecOps. So jumping onto DevSecOps. So we are very lucky. And Agile. Well, Agile was useful in a way. And well, actually, the Agile was adopted. The DevSecOps was adopted by US DoD, which is the largest organization. Tokyo Mitsubishi. I don't want to speak bad about Mitsubishi, but I've been a customer of Mitsubishi Bank, and Sunday, late night or midnight, I cannot make deposit or money transfer of my Mitsubishi Bank account because it is maintained at late hours of the weekend. When I want to transfer money using application, and the service stops in Sunday midnight. And 78 million accounts they serve, they say. And Sunday night, they suspend the service. It's not acceptable. But in my company at the Zoom meeting, they also conduct a refresh, and Zoom not operating properly, and the Windows update was halfway done and not complete. And Apple's flow is that it is slow or heavy. But I use it once in a while for Windows. So when I open it, they need to refresh, and I have to reboot the system. In 1990s, beginning of 1990s, the OS I used never rebooted. And that's how I created, and including a server. I think my partner also created similar things in Japan and also in the US in a Roppongi building. Web and DNS or mail servers, everything was written. And they operated on memory. So conceptually, it operated on memory. And many times I upgraded, but they never stopped. So it's a non-stopping server, and all the security models are embedded. And hypertext HTTP, www.co.jp/something something, HTML, that Unix or Linux directory code is all matching. So nobody tells the internal code to outside. You don't tell your rover about the location of your safe gate. So it is real-time generation. It's completely encapsulated, and a bulletproof server for Japanese version, and also the US version in LA. Its characteristic is non-stopping on OS level. So it is on Linux machine, but all threads are replaceable. And starting from the core, and the servers rewriting is done only with the change of object, exchange of object. At the DoD with the rebuilding, and I got kicked out, but and currently at the Barney's New York building in New York, and it's been more than 10 years. And at that time, only at the time of the moving, I stopped the server, and that was the first time I did that. So in rebooting. And whenever I open Zoom meeting, the Windows update kicks in. So it's really, really late. And architecture still running on Mark, same for Apple. But depending on how you do it, the initial rebooting, you can start with Windows and conducting a rewrite. That's exactly the current logic of DevSecOps. So using the specific architecture, you can run it non-stopping. 78 million accounts, only 78 million accounts, and it stops every Sunday night, and only for the banking services. And Netflix, probably 200, 300 million users, and people using family accounts, and they are tracking everything their users are doing. But they never suspend the business in Sunday midnight. That's because they are abiding by the DevSecOps type of policy. So, and the space astronauts or the aircraft cannot stop at the time of a refreshing or upgrading. So the current DevSecOps, as a software engineering, we as a end user or not, we as an end user of a Mitsubishi Bank, when we use a service, those requirements are naturally realized, executed through DevSecOps. When you understand that, our question should be, why not DevSecOps? The answer that we are doing things with a way, existing way. You shouldn't, is my answer. And now digital agency is saying DevSecOps, and the top of the top is now pointing DevSecOps. And we've been saying this for 3 years. And today, we, as a Carnegie Mellon, and Pentagon and Carnegie Mellon nominated the Nirahara-san as the evangelist of DevSecOps, and he is available when you request his service or his lecture. Please use that. That's all from me. Thank you.
Thank you very much. With the history, software, hardware, he has discussed, he is the living witness of the history. Based on the current resources, on top of that, various things are happening. But in 1980s and 1990s, we have been looking into the history. Well, he has been looking into the history of computer science. He was one of them. Architecture itself could be updated. That is a sensitive issue by him. Oh, it's not me, but I would like to ask. Well, I'd like to hand over to the next gen. But always his discussion is very much instructive and insightful. So now this the nearing to the closing time, and what did you think? I would like to share with you the tomorrow's agenda. Starting from 9 a.m. tomorrow, we will have a session. So everything is the major items I would like you to look into. First of all, keynote speaker, Mr. Carl Fox. Up until recently, he was a software engineer at the U.S. Air Force, and ICBM is run by software. So unless you do, you are going to lose. So here is the title: that Rise of the Software Defined Weapon, Accelerate or Lose. And Dr. Linton Walls, there's no title available, but it was, I think it was this morning or yesterday, we received the documentation, cyber resilience. So he's going to talk about the cyber resilience. Now, Mr. Reinhardt from O'Reilly, now he is going to publish a book. And Mr. DJ Schnein from Yahoo, I am sure that the materials will be coming today. The title is going to be updated, and then followed by Hasan-san, and then Mr. Oshiba. The vulnerability of AI will be discussed and how it should be protected. And earlier, I have mentioned from NTT Data, Semia-san is going to discuss over the SBOM, and Mr. Koike, as a finalist of DEFCON, and he's the youngest one. He is one of the finalists. He was the finalist. And then Mr. Fujisue, he's going to talk about the cyber resilience at Japanese universities. And then from NLI, Mr. Fukuzawa is going to discuss over the DevOps success recipe, as there are many different case studies from India, offshore testing, and data science. Also, we invite from the UK, Mr. Mario Platt. He's very famous through a blog, but the security is going to evolve, accommodating the environment. The other one is Mr. Nicholas Shannon, how the DoD transferred to DevSecOps. And then we also invite the last keynote speaker from METI. He's going to discuss over the policies on cybersecurity in industries. So, well, we should focus on everything. Maybe you could be a little bit tired. However, hopefully that you will stay with us all day. Again, for the NTT Data that has been appointed as sponsor newly, and the GMO startup companies, robust intelligence reseller agency, and supporters. Every year, the embassy of the US and MEXT and MIC, the digital agency, and Carnegie Mellon, and Cognitive CTF, which is the organizer this year. So we have been receiving these support from them. For those sponsors and also these supporters, we also shared some digital agencies documentations. So starting from the how the software development should be, and covering to the robustness or the economic growth in Japan, which we would like to contribute to this event. So I'd like to ask you to be with us tomorrow and to have an active chat. This is all. So I'd like to close. Now, I would like to share with you the messages from sponsor before I close. So looking forward to seeing you tomorrow again. Thank you.
DevSecOps Days 東京は DevSecOps を推進するためのコミュニティ活動に賛同してくださる多くの企業・団体から支援を受けています。プラチナスポンサー NTT データ、ブレインパッド、コグニティブリサーチラボ、ゴールドスポンサー NRI セキュアテクノロジーズ、 GMO サイバーセキュリティ by イエラエ、シルバースポンサー HRD プロファイルズ、スタートアップスポンサーロバストインテリジェンス、リチェルカセキュリティ、講演アメリカ大使館、経済産業省、総務省、文部科学省、 デジタル庁サイバーセキュリティ戦略本部、カーネギーメロン大学ソフトウェアエンジニアリングインスティテュート、カーネギーメロン大学サイラボ、コグニティブ CTF。世界から届いた食材が彩るディナーテーブル。約束の場所に時間通り安全に到着する交通機関。どこでも安心して受けられる医療や薬。遠く離れて暮らす家族に贈る誕生日のプレゼント。その日常は人や物をつなぐ仕組みで支えられている。お客様と社会と、そして世界中に広がる仲間と共に新しい仕組みを作りつないできた。世界は常に変化を続け、時には想像もしなかった困難を私たちに突きつける。必要なのは何ができるかではなく、何をすべきか。社会があるべき姿とは何か。次の世代にも続く本当に豊かな暮らしとは何か。それを見つめ、私たちは行動する。NTT データ。
ビッグデータや AI 技術が脚光を浴びるデータの時代がやってきた。巨大企業もベンチャー企業もデータを大きな経営資源と捉え、ビジネスに取り入れようとしています。15年以上前からデータ活用の可能性をまっすぐに信じてきた私たち。今こそ一緒にデジタルトランスフォーメーションで開けるドアがたくさんあると思うのです。
持続可能な未来につながる扉。
成長し続ける。
できること広がる。データ分析の民主化。
最適な意思決定。
挑戦できる未来。
ささやかな幸せにあふれた日常。
成長です。
ときめく。
顧客体験を磨き続ける世界。
豊かな社会。
意味のある仕事を作る。
誰もがビジョンにチャレンジできる。
誰も想像できない
大きな成功。
イントゥリアンノン。
目から鱗の瞬間を提供する。
製造の無人化、子どもたちの未来。
データ×ワクワクイコール未来。
できたらいいなを形に。
仲間の笑顔が未来の笑顔を作る。
未来は作るものだというふうに考えているので、仕事を通じて新しい価値をですね、創造すればですね、日本がまだまだですね、成長できる、面白い機会を作ることができると思っているので、かなり広範囲のビジネスをですね、僕らはご支援できるんじゃないかなというふうに思っています。
その意志が世界を守る。テクノロジーは常に進化する。インターネットが人々の間に広く普及し始めてから、様々な技術が加速度的に進化し、派生し、広がった。気がつけば、私たちの暮らしは便利さという名の下で大きく様変わりしてきた。テクノロジーをどう使うか、それはその人間自身に委ねられる。人はいつの時代も人が作り出した矛盾にとらわれている。善か悪か、勝つか負けるか、傷つけるのか、守り抜くのか、そのパラドックスに常に挑んでいる。今やビジネスだけではなく、日常生活においても IT の力が不可欠になり、全てがネットワークでつながる時代。24時間365日、社会全体が常に IT の引き起こすリスクと向き合わなければならない。時代の変化を見極め、新たな知識を蓄え、培ってきた技術と経験によって決して負けられない戦いに挑み続けていく。恐れずに進もう。あなたの揺るぎない意志が これからの時代を守っていく。その仕事で人類の豊かさを確かなものにしていくんだ。さあ、プロフェッショナルとしての誇りを胸に、この社会を前進させていこう。その意志が世界を守る。NRI セキュアテクノロジーズ。
コグニティブ CTF は誰でも楽しくセキュリティを考慮したプログラミングが学べるゲーミフィケーションプラットフォームです。すでにソフトウェアエンジニアとして活躍している方も、プログラミングに興味のある中学生、高校生、大学生でもどなたでもゲーム感覚でお楽しみいただけます。コグニティブ CTF は政府機関の研究開発プロジェクトとしてコグニティブリサーチラボと東京大学、京都大学が共同開発しました。軍事大国の現役サイバー兵士が取り組むような難易度の高いものから、初めてプログラミングを学ぶ中高生の初心者の方でも楽しめるものまで、多様な問題を取り揃えています。コグニティブ CTF に取り組むことで、基本的なコーディングスキル、暗号解読、フォレンジクス、リバースエンジニアリング、バイナリ解析などに関する問題を解きながら、ハッカーとしてのスキルを向上することができます。悪意を持ったハッカーがどのように攻撃してくるかについての知識がなければ、ソフトウェアの安全と安心を保つことはできません。現代はあらゆるソフトウェア開発者にハッカーとしてのスキル習得が必要になっているのです。ぜひあなたも一度コグニティブ CTF でハッカーとしての腕前を試して楽しくスキルアップしてみませんか？ QR コードを読み取ってぜひ参加登録をお願いします。どなたでも無料でお楽しみいただけます。
インターネットの発展は私たちの生活を便利に豊かに変えました。今では水やガス、電気と同じくらい生活に欠かせない重要なインフラです。会社や学校、病院、銀行や工場、ありとあらゆる場所とシステムがインターネットにつながっています。そんなインターネットがサイバー攻撃の脅威にさらされているなんてあってはならないと私たちは考えます。私たちはサイバー攻撃で使われる脆弱性や攻撃手法を日々研究しています。その結果、なんと直近1年間で約30件のゼロデイの脆弱性を発見しました。私たちは悪意あるハッカーが攻撃するよりもずっと前にお客様のシステムのセキュリティホールを見つけてご報告します。私たちはこれまで先進的なセキュリティ技術を研究し、知識を共有してきました。私たちはこれからも企業とシステムを利用する全ての人をサイバー攻撃から守ります。目に見えない脅威から暮らしを守る、日本を守る。全ての人に安心と安全なインターネット。
HRD グループは科学的なアプローチで人事や組織の改革を強力に支援しています。今、多くの企業がデジタルトランスフォーメーションに取り組んでいるのではないでしょうか。デジタルテクノロジーを活用することにより、営業やマーケティングの見直し、業務プロセスの自動化がさまざまな企業で実現されています。では、人材や組織に関してはどうでしょう。一人一人の才能や個性に合わせた適材適所の実現や効果的なコミュニケーションの実践は、デジタル化とは無縁の勘と経験に頼っているのが現状ではないでしょうか。このような勘と経験に頼ってきた人事や組織の課題もデータにより解決する時代になってきています。私たちの提供するディスクとプロファイル XT は科学的検証に裏打ちされた人材測定ツールです。一人一人のモチベーションの源泉やそのポテンシャルを見出すことで組織や人材の課題を解決します。全世界でこれまでに6000万人、10万社、日本でもこれまで120万人以上の顧客が効果を実感しているソリューションです。これからのデジタル時代の企業における改革の本質は、 人と組織のトランスフォーメーションにあると私たちは考えています。HRD グループのディスクとプロファイル XD が組織や人材の改革を可能にします。効果的なコミュニケーションによる組織力向上に興味のある方はディスクで、社内の適材適所の実現や人材のポテンシャルを見出すことに興味のある方はプロファイル XT で検索して、ぜひ一度ホームページからお問い合わせください。